And today we will have a speaker from Global Foundry. He is called Semke. So he is a distinguished member of technical staff from Global Foundries. He has been with the companies for 10 years already. He leads a global organization responsible for providing critical services that supports semiconductor design. So please join me to welcome him for the Bridging Semiconductor Designs and Manufacturing lectures today.
All right, thank you everyone, and thank you for the opportunity to be here today. So go ahead and go to the next slide. So today I'll give a brief introduction about me and my team and how we fit into Global Foundries and how we fit into a foundry business model. I'll give a brief overview of Global Foundries. And then I'll talk about, and this relates into what my team does, how we take semiconductor technology and then ideas for designs and how we bridge those worlds together and the opportunities that are available around that. A bit about my Global Foundries, my journey, and a few links and follow-ups from there. So I have 21 years experience in the industry in design enablement. So design enablement within a foundry is being able to take the process technology, describe it in a way, and provide enough information, collateral, and capabilities that someone could do a design in it. That's been my path, starting with some things I'll talk about later, like PDK, and into other areas of that. I'm an Illini. I come from UIUC. My research in graduate school was substrate noise analysis, which is really enabling someone to understand their design better. I started with IBM in 2004 in Vermont, their microelectronic division. There still is a fabrication facility there. And then in 2010, I actually came back to Indiana. I'm from downstate Illinois, and I work out of Indianapolis area. So I am away from the fab. And since then, we transitioned to Global Foundries in 2015 when they acquired IBM's microelectronics division. I did attend Purdue for 1 week many years ago, or at least lived in the dorms and ate the food at a golf camp. That's about my extent with Purdue. For those in Indianapolis, I'm glad to hear you're here. My wife works for IUI, so we're definitely down on campus often there, but on the Indiana side. My undergrad internships were in construction equipment, and I want to highlight that. So it was automated vehicle research, but the things I learned there in those internships with Deere and Caterpillar in different areas, right, they're very pertinent to us in the Midwest here, are definitely applicable to what I've done in industry. And finally, my job title is Distinguished Member of Technical Staff, so I'm a technical executive. What that means is I can take roles and have taken roles where I'm leading initiatives and projects without direct reports, and working across organizations, and also currently I have an organization where I'm a group leader and working with a larger team that I manage. So my team and my focus, I'm not on the manufacturing side. I'm not in the fab, and I'm not, working on the process line. My team's mission is to make it easier to design and manufacture chips. So the goal is for when we have a process and we have a customer that's designing it, how to make it easier, quicker, faster for them to do so. So within my team, I have over 40 engineers and a global presence. I'll try to use the clicker here. So we have fabs and global foundries in Malta, New York, in Burlington, Vermont, in Dresden, Germany, and in Singapore. So I have people at those facilities that are working with, say, some of the manufacturing team. But again, we're not doing manufacturing. I'll get more into what we do in a moment. They also have team members in California, Texas, Bulgaria, and India, and some of our engineering centers as well. And within our team, we have a broad range of expertise. So one of the things I want to press upon today is, we are a foundry, but it's not just about people who know process technology and materials and such. Within my team, we do have people who know process technology, more from the point of view of how we can model it and understand it and provide it to someone external like a designer to understand. People well-versed in circuit design. In software engineering, I have software engineers who can create, deploy applications and provide them for usage internal to Global Foundries and to our customers, and also people involved in machine learning and AI. I did recently hire Purdue Comp E last year, so Purdue grad, that's part of my team. And his role is to develop AI solutions to help with the design process. So as an example here, the type of skills in my team that we're looking for are people who can take something like AI and apply it, but have some of that background right in the domain in order to understand it. So a bit more information here about GlobalFoundries. So I'll focus on a couple areas here. We are a semiconductor manufacturing company. It's over 2 million wafer shipments in 2024. So our core mission is to sell wafers, produce and sell wafers. Now again, as I go through the talk, some of it will be more around the services and what we do around that, but that's our core mission. As I mentioned before too, we have 4 manufacturing sites across 3 countries. So Germany, Singapore, United States, that give us a global footprint and supply chain for our customers. In terms of the markets that GlobalFoundries is involved in, some examples of this or a sampling of these is automotive. So we're involved in the automotive industry, automotive chips, home industrial IoT, so internet AI at the edge, So I had AI at the edge applications. I'll talk a minute about some of the technologies we have and such. Smart mobile devices. So within the smartphone, several chips included, and many of those components are something we produce. Communications, infrastructure, and data centers. So silicon photonics. So doing optical interconnect and integrating that with a silicon wafer. And finally, aerospace, defense, and critical infrastructure. Again, I mentioned we have a global presence. We have the ability to source technologies from multiple locations globally, and that makes us very resilient to supply chain challenges. So in terms of technologies and platforms that GlobalFoundries is involved in, and this chart here, there's a lot of 3-letter, 4-letter, 5-letter acronyms here, and I'm not going to go through all that. I try not to get into those too much. But I'm going to focus here on the top line. So we have different platforms of technologies. Something I didn't bring up before is if we look at the history of GlobalFoundries, and even before when I was part of IBM, we were always going to the next leading edge technology, right? Going down node to node to node. In 2018, GlobalFoundries made the decision to focus on differentiated technologies. So instead of trying to keep going down node to node, it's how do we add value onto the technologies we have and make differentiated technologies on more mature process nodes. So in terms of the type of applications and technologies, power, so power delivery, power chips, ultra-low power CMOS, so we mentioned AI at the edge before, low power, less battery consumption, what have you. Silicon photonics, so optical interconnect, in data centers and such. And then RF applications, high frequency applications, RF SOI, millimeter wave, SIGI applications. And then finally, feature-rich CMOS. And feature-rich CMOS is taking a base technology and then adding very specific applications or requirements for customers to meet their needs. So far I've talked more about the markets that GlobalFoundries is involved in and some of the technology platforms as well. But going forth, I want to talk a bit more about really kind of what my team does and involved in and different aspects of what a foundry does and how to make a design successful. So if you're trying to take a process technology and you've got an idea for design, how do you merge these worlds together? And our goal is to be able to take the technology and the expertise and get it as much into the hands of the designer as possible. And there's different ways this is done. I'll step through a few of these here. The first one is electronic design automation, or EDA. These are a set of tools that are used to create, verify, design, simulate, improve manufacturing of a chip. These typically come from outside the foundry with EDA provider. Few, for example, would be Synopsys, Cadence, and Siemens in Keysight. And so they provide these softwares, they provide them to the design teams, they sell to design teams, to the fabs too, and others in order to design chips. But what is critical within that as well, and this is a domain I've been primarily involved in over the years, is the PDK, or Process Design Kit. So the PDK is a set of files, models, decks, and tech files that describe a given technology. So if we're talking about silicon photonic technology, for example, it would have a PDK associated with it. And that would have all the necessary information for these EDA tools to be able to provide the designer with information about, are they passing the rules that will allow them to manufacture with us? Are they meeting the performance they expect to see? So this is what the PDK comes in as, a foundry deliverable that is then married with these EDA tools to give that insight to the design teams. IP, or intellectual property, is reusable, predefined design blocks. You could think of it as a small circuit that a company will go in, or within a foundry will go in, design it, manufacture it, prove it, and then that block will be available for someone to design with later. It's pre-characterized, they know it's going to work, and they can give them a start on their design. And finally, design services, which is applying expertise in chip design. So all these are different aspects of the process of going from a technology into getting something a designer can use. So if I look up here on the upper left, from an overly maybe simplistic point of view, we start from a technology. So this is what's in the fab, right? The process that's being defined. And then we add in these different areas here that I mentioned, the EDA solutions, the PDK from the foundry, IP that's provided, and then different services. That goes to the designer who has an idea. He gives his blueprint, his tape out, what have you, to the manufacturing. There's some more services involved there, and that's how we get to a product. So my team is involved here in this part here, in my organization. I'm providing these services and integrating with different providers for those in order to make a design successful. So this view here is of the ecosystem of all the different companies and partners that come into play to make a chip. Global Foundries has over 100 ecosystem partners producing IP, providing EDA solutions, design services. FDX and RF are more specific technologies where they provide support to, and then OSAT would be packaging. So I know Purdue has quite a bit of involvement in advanced packaging. OSAT is involved with packaging. So over 100 partners are involved in our technologies to bring them together with designs. And you can see some of the numbers here about the number of IP we have, the number of client we service, and what have you. And the best example has been given to me. I guess I put my cell phone over there, but if you look at a smartphone, right, there are hundreds of companies behind that phone, hundreds when you get to the different chip manufacturers, but then all these different companies behind that. So with this comes challenges. Nothing is ever easy. And with the challenges we have in terms of providing these types of solutions to allow someone to design in our fab, it's mostly around time. The reason I have a stopwatch here is everything relates into time, and how quickly someone can produce their design, manufacture it, get to market, what have you. So the first challenge is accelerating the time to product. So we're looking at how do we deliver this collateral and these tools faster? How do we deliver a description of the process technology faster to the design teams? How we deliver the EDA solutions more quickly, how to develop and characterize and deliver this IP more quickly. The second part that's important is how quickly someone can adopt these solutions. So once we get in place with design teams, how quickly they can pick them up, run them, and use them. And then reduce design cycle, how effective these solutions are in terms of them being able to produce their design. Accuracy is another consideration. So first time right design, first time right, get the silicon back or your chip back, it works, okay, move on. If we're not accurate, you might need multiple spins, you might lose your place when you're trying to get to market. So that's critical as well. And then finally, I talked about how there's so many partners involved with this. These complex interdependencies and managing things is another challenge. So with this comes opportunities. And when I was putting this together a few days ago, this presentation, I started to think about it a bit. And 20 years ago, I would have given the same challenges. So we would have been, okay, at the time I was working in what I called PDK in a very small part of it as an engineer. And at the time I said, okay, we need to be faster. We got to be able to get our PDK out faster. We got to be able to have it more accurate. We got to be able to manage our dependencies from the manufacturing fab and from EDA and what have you. What's different today is the opportunities we have. So the rapid expansion, of course, of AI, machine learning, infrastructure, compute, you name it, gives us opportunities in this realm that I'm talking about to do much more than we could do before. And that's part of what my team's mission is at Global Foundries, is taking these solutions and applying them into these challenges. So if we look, for example, at some of the things that we're doing or are looking at and we'll be, let's say, exploring as we go forward or implementing, AI copilots, for example. So I have software engineers on my team. So they're definitely using copilots, right, to write code. But there are other places we use copilots as well and train them in order to make this easier to do. Machine learning generated models. So part of my team's mission is to create models of the devices that are provided in a PDK, a FET, for example, or a capacitor, and to make those easier to do. There's papers from some of my team and my colleagues and others out there about using machine learning in order to take the measurement data and calibrate those models and produce them. Automated workflows. So when you're going through a design, and a lot of our EDA partners are heavily involved in this, and you can see it on their websites and their publications, automating the workflow to go through a chip. And another one, for example, is using GPU compute for some of this, right? GPUs are becoming more prevalent, can use that compute not just to train an AI model, but actually to run some of these solutions as well. So these are some of the opportunities that we have right now. These are things that make it still interesting, right, to get into this realm. And as we look forward, these are what we are looking for in terms of, as we bring in new college grads and new persons in the global foundries, we're looking for these skills, right, to be able to expand into these areas. All right, so I'm going to give a little more information about global foundries. So global foundries investing in team and communities, right? So in terms of what global foundries does with the employees and then also with the communities around us. So the examples here is there is a culture of training and continuous education as part of the company, shown by the number of hours here. There's many resource groups, worldwide as well, that are part of our culture. And then also we have the giving campaigns as well, working out within the communities that we live in. GF Labs is the driver of our, say, innovation and our research within Global Foundries. And part of their mission is to work with the R&D ecosystem. And as you can see here in the upper left, Purdue is one of the two strategic partners in the with GF, both the United States, but with Global Foundries. So we do have a deep relationship with Purdue, different programs that I've learned a lot about today in my time here. And recently we had several students come into Malta, into the fab as part of one of the programs. So there's quite a bit of engagement here between Global Foundries and Purdue. So I'm going to give a couple slides here and just talk about my journey a bit and where I've come from and where I've been, and just a few tidbits about that. So my career path, when I started to put this presentation together, I was thinking about how best to describe this. I had an example from a colleague who did this a couple years ago, and I was starting to look through it, but the different job titles and companies, stuff like that, maybe not be quite, it is there, but may not be quite as interesting. When I started to look through it, I started to write it down. I was like, okay, I can see where this is kind of going linear over the years, right? Pretty much stayed in kind of the same place in terms of company. We were a company, acquiring company within there, but starting off as an engineer, then a project lead, then more projects and such, and then on through to being an organizational leader. So, when I first put it together, it looked like to me it was a straight down path. But as I start to think about it more about, the path I've taken as an example, it actually is much more jagged and how it's progressed over the years. And there's also branches and opportunities that come as well. So that's why I like this map view, because you can see that there's multiple routes to go down. It is a bit more jagged. But, as you go forth in this industry or whatever industry you choose, there'll be times where you'll look to take a lateral move, right, and try to learn something new. And that's, what I've tried to represent here in my career, is to kind of go down through. There's times when you might step back and actually take less responsibility. It's almost like stepping back a bit and trying to learn something new. And that really is what's represented here as well. So, no matter what it looks like, there's a lot of opportunities that come through. There are a lot of, let's say, different ways you can go. But again, what I want to highlight here is even if it looks very linear, it is not nearly that way as you go through it. And then a few things about, say, what I've learned, over my time. So first off is don't relax. What I mean by that is don't be, say, nervous and apprehensive and, what have you, or be nervous and apprehensive, what have you. It's more about not being complacent. So as we talk about these different technologies that I was showing here and these different opportunities we have, what I've learned is if you become complacent and you don't keep moving forward and trying new things, right, then you don't really, it's not about the competition with others. You really don't get the opportunity to do the things you want to do, right, and how you want to keep growing and advancing going forward. So being able to continuously learning about new technologies and what is very important. Second is pursue opportunities. So at first I wrote down seize opportunities, but not every opportunity necessarily should be seized, right? You could get, jump off every 2 weeks and keep jumping companies. That may not be the best thing to do. But really pursuing opportunities and looking at saying yes when an opportunity comes about. So for example, one of the things I have found in my career is if I get offered to do something, I have no idea what the outcome is going to be, I don't know what it is, you really step back and think, what will I learn in the end? And if it does fail and it doesn't work out, am I learning something that still gives me something new in my toolbox or what have you to move forward? Third is embrace working in the gray. So within engineering and what we do, we often do not know what the outcome is going to be. We don't know what the final result is. So one of the most important things I have found is being able to enjoy the challenge, look forward to the challenge, and not knowing what is coming next and what the outcome will be. And finally, collaborate and recognize others. So collaboration is key. I mean, it's kind of a buzz, but it is very important as you go through to work with others, collaborate with them, and even more importantly, recognize their contributions. We talk a lot about networking, and networking, yes, is maybe a handshake or dinner or what have you, but actually making something with someone and producing it and coming out with a result is something that you can build on. Then over time, as you go through your career, you have someone you can work with, engage with, and build more things on top of. So a few links and follow-ups that I have here. First is, here are some links about Global Foundries. So if you have any questions or anything you want to look into about Global Foundries, various links here about news and careers and such. Different opportunities here to connect with GF as well. And then finally, mentioned earlier that I believe it was mentioned earlier that there's the career fair next week. So Global Foundries will be here. There'll be an info session in the morning. So I'll be back here as well with some of my colleagues on Monday morning with an info session. And then also we'll be at the career fair in the afternoon. Okay. So again, I appreciate the opportunity to speak to you today, and like to know. Let's open up for any questions.
Does anyone in the classroom right now have a question before I read out the questions?
Hello, I guess I'm just a little interested in how PDKs interact with like circuit design software. Like if you give a company a PDK and I'm using something like Simulator 3D, do I get like plugins or add-ons, or could you just go a little bit more into detail about how PDKs connect like the people making the circuit and the people designing the circuit?
Yes. Yeah. So for example, if I am simulating a device model, I have a device I want to simulate, for example, and so I'm using a circuit simulator like an HSpice or Spectre. So the PDK would have in it a model, and that model would have all the characterized information about that device. So essentially what this IV curve looks like, all those different aspects of it. So the PDK would have that file that says, okay, for this FET, this is the description of all its electrical characteristics, and it's written in a syntax that simulator would understand. All right. So essentially, it's that file is written in that software-specific syntax with the information needed, and then when the designer gets it, then they can take that file essentially and plug it in, what have you, provide it as an input into that.
Okay, so one question that student pre-submitted. Why did Global Foundries choose to stop pursuing nodes below 10 nanometer? And how does focusing on specialized platform give the company a competitive advantage?
All right. So going beyond 10 nanometer is an extremely expensive proposition, right? And there's a matter of what the ROI is as you move down those nodes. So when GlobalFoundries made the decision to pivot, that's a decision on, instead of investing very heavily towards that leading edge and putting most of your investment into that, it's instead a decision to invest in differentiated technologies. And as we've seen, and that gets into the applications and markets that we've shown here, by doing that, we're able to meet the customer need, meet the customers where their needs are. So one of the things that our leadership determined, and one of the reasons that change was done, is that there is a very significant need for these differentiated technologies at things that are not at the very leading edge, right? And so I will say this as an example. I was on the leading edge, let's say, train for my career for many years. And so I was working on the leading edge, up until when GF made the change. Now I'm working on technologies where maybe we did the base technology and I worked on it literally 15 years ago. But now we're doing some really cool things in that technology on top of it that I would not imagine back then. And so that is, some of the reasoning why GF made this decision, but it's also some of the things that I'm seeing day to day. On a personal level, when we first made the decision, or GF made the decision, to not do the next node, personally, because I had been on that next node, I call next node train for years. Every 2 years, something new challenge-wise. My personal question was, am I still going to be excited every day? Is this still going to be interesting? And 7 years later, my answer is yes, because of the kind of different technologies that we're applying on top of those process nodes. I would say my challenges, because of adding differentiation, and my challenges, because I'm working very closely with customers to do that differentiation, are probably more compelling and invigorating even than when I was going node to node.
Hi. What advice do you have for students who are really interested in semiconductors, but they don't know what field? Like Global Foundries, you guys have PDKs, you guys have manufacturing. How did you know that you wanted to work in PDKs, or how did you find that out? What advice would you give to someone who's exploring that field?
Yeah. So from my perspective in educationally, so I mentioned I did internships in construction equipment, right? Which is about as far away as you get from semiconductor. I had an opportunity for a research assistantship in a group that was doing ESD modeling and substrate analysis, and that kind of clued me in. So that was part of my perspective, was seeing that on that scale. But to your question, my advice would be, as you go through your college curriculum, right, and especially if you're in a EE track or what have you, is try to get a sample of different parts of the spectrum. So for example, I know in my career, and when we're doing PDK, we kind of have to know a bit of everything, right? Because I got to understand the process technology, I need to understand software, I need to understand design. So for myself at least, and the kind of engineers that I'm hiring and into what I do, but also what I see for getting that breadth is, make sure you take a course in semiconductor physics. You probably have to anyhow, right? But in process. Take courses in circuit design and take courses in software as well, and see all aspects of it. I think that's the best advice I could give in terms of how to do it as a student. The other part too, I would say, is if you do get opportunities, to do internships and research and what have you, finding an area of research where you do get a little bit of that breadth and you can stretch across it a bit, I think is also a place to look at as well.
What are some of the internship or co-op opportunities or just general opportunities that Global Foundry has to offer for undergraduate students?
Okay. So definitely Global Foundries has a large intern presence, and I don't have the slide here. I know it's in for Monday, but some amount of interns that are coming from, say, Purdue into Global Foundries. But I can talk a bit about it. So, we would look at the point of view of, okay, we have people that are in the manufacturing side and what have you, right? But there's also opportunities in supply chain, right, in those areas. I had 2 interns this summer, so I'll give you an example of my 2 interns were doing, because it's going to be a bit different. So I had 1 intern this summer that was working on machine learning models in order to model devices, or I mentioned compact models or transistor devices. So this intern was working on creating those machine learning models. This intern is not let's say a process person, for example, but she's able to do that with us. I had another intern that was working on small language model applications for some of what we're trying to do for solutions. So within GlobalFoundries, to your question, we do have it from the semiconductor point of view, but we also have opportunities around software, AI, ML, and then into the business side as well.
Okay, so next question. How will the next generation of photonics technologies change the chip manufacturing landscape in the near future?
I think photonic technologies, as we see it, and the way that I would say it, I recently went to our technology summit in California, where our technologists and our leads were presenting our technologies and where they're going forward. So now, at this point in time, we're ready to ramp and launch our photonic technologies. And what we foresee is in these applications I was talking about here with data centers, infrastructure, what have you, that will provide a means to accelerate capabilities in those areas. So that's why I think for photonic, it's a newer field for us, or not for us, it's not new for GF, but it's a newer field, it's a newer application. But this is something that we're bringing to manufacturing now, and it's going to allow us to reach new applications.
Going back onto the GlobalFoundries focusing more on 10 nanometers and above, can you touch on maybe more on the technical side of how GF continues to innovate or better integrate its technology to keep improving in that region?
Yes. So, some of the examples from a technology point of view is investing, if I go back, maybe I'll just go back a few slides here. Just give me a moment. Yeah, so this is a sample of some of our technologies here, and I could talk to it a little bit, right? So you see, for example, gallium nitride. Oops, a point up here, not down there. So gallium nitride. So gallium nitride devices for power in RF. So that is a differentiating technology, right? That's not something that has been produced by many people before. It's not something that was there many years ago, what have you. That's a differentiated new technology, right? FDX. So our 22FDX platform, for example, 22 nanometer, which is a very powerful technology. That's also an example of a differentiated technology, different type of technology, right, than would necessarily be done on the leading edge as you go down, right? And then as we get into some of these other areas as well, I think photonics, we said the question there, that's another example as well, innovating in photonics. Another place too that would be innovation would be advanced packaging solutions. So finding new ways to package and such. So really finding all these different, say, features or applications or capabilities is where GF innovates. And what's really interesting too, I don't have examples here on the slide, is this feature-rich CMOS. So these are technologies where this base technology has been developed for quite some time ago. But then there will be a need that a customer has in that technology or an application, and then we can provide some innovation for a certain type of device, a certain need, and put that on that technology and provide it to them. So again, that's some of the innovation here. Some of it's process technology in terms of like a new technology type. Some of this is taking something that hasn't been done before, say it like this, has been done before but somewhere else, right? And applying it into a technology meeting a specific need. Yes.
So you guys are obviously very, leading edge on the technology side, but how do you stay competitive on like the supply chain and business side?
So it's a bit outside my domain. So I'll just say that right now. Good question. It's outside my domain. But I know in terms of like say talent and such, I know that there is a heavy focus on bringing in people that are very talented in those realms. There's different programs that are in place right now, rotations and such, in order to make sure that we have a pipeline in those areas. Also, from a supply chain point of view, I think if you get into, I talked earlier about global foundries in terms of having a global footprint, right? And I believe that relates into supply chain as well. So if you're manufacturing a global foundry, you would have the capability to have regional-based manufacturing, or a given product might be able to be manufactured in multiple sites. And that's another aspect too that comes into place to stay relevant, especially in today's day and age. Yes.
You mentioned like aerospace. I don't know, does like the design or the manufacturing process change when you're considering like putting these chips in extreme physical conditions?
Yes. Yeah. So I mean, if you get into the extreme conditions and stuff, yes, then you get difference in a process point of view, right? You also get differences, in automotive is an example too, in reliability. So that's an interesting area as well, right? We're talking about taking technologies into different applications. Part of that taking different application is you have different reliability requirements, right, that you have to meet. So you might have a technology that's been manufactured for a certain application. Now you move to an application that needs, let's say, higher reliability, right? And then you might have to, not just run more data, you might have to make some changes, right, in order to meet those requirements.
It feels like semiconductors are getting more and more tied to like national security.
Yes.
How does a global, companies such as yours kind of navigate those regulations with maybe restrictions on different countries and what you get to?
Yeah, so definitely that's a supply chain earlier, right? So I think that's a significant part of what we do in terms of the chain of custody in chips. So in terms of all the suppliers and everything that happens, having a very tight understanding and control of where the chip is at, who is involved with it, and where it's going, right? So that's a big part of what we do from a manufacturing point of view. It's also critical in terms of persons and such too that are involved in the process. So that again, I think that's and that's I'm trying to think if there's any other aspect to it, but I think that's probably the main thing is keeping the chain of custody, understanding where the chip is, where it's going to be applied to, and knowing what the companies you're dealing with as well. Yes.
What's the difference between FinFET and FDSOI?
Okay, so FDX is a silicon on insulator technology. All right, so you have an insulator with silicon on top. So it's and in terms of application space, we have FDX, low power IoT, we have millimeter wave applications, there's quite a few applications on it. And so that is on an FDX point of view. A FinFET is a non-planar transistor device. So if we look at transistors in most of our technologies, I don't know, probably in early classes you might have seen a picture of a transistor. I'm going to try to do it with my fingers. So you have your source drain and you have a gate running over the top, right, like this, and the current runs in between. So if you have a FinFET, for example, what you have is you actually have active regions that are fins. So you have your gate running out and you have these fins kind of running through. I can't go through my finger, but running through. And so it actually looks like fins coming out of the gate of the transistor. And that's one of the, I'll say tricks, but one of the process changes that was done to move down to a smaller process node. So in order to get the transistor performance that's needed as you go down into 16 nanometer and smaller, this is what was done to the transistor, at least at that time, in order to be able to get the process and performance that's needed. And then if you go down to smaller nodes, you can see different applications as well.
All right, guys, let me pass the microphone to you before you talk.
Okay.
Hi. So my question is, when you're in any process or any part of the design process for a chip, what are you thinking about in terms of manufacturing?
In terms of, a little more.
In terms of manufacturing the chip.
As a designer.
Yes, as a designer, yes.
Okay. So I think as a designer, part of what you're looking at is passing all the things that we're asking you to pass when you come into the fab, right? So are you passing the ground rules, for example, as you manufacture? Are you meeting your electrical characteristics and such? But if you go beyond that, there's also things you'll be thinking about in terms of reliability. So if you're designing, for example, you're going to want to understand for your design how long it's going to be powered on, at what temperature it's going to be running, how much say stomach you have for air, I guess you could say, or for something to go wrong. All those considerations come together. So when you're using the design kit, like I mentioned, you need to have those things in mind as you're going in to do your design in order to understand, okay, these are the requirements I need to meet when I go to manufacture, and this is what I need to have happen. So that's part of the aspect of it too. There's also considerations like design for manufacturing and different applications there and different tools that are provided that you also, depending on your application, can apply those tools and try to find out, okay, where's potential hotspots? Where's potential issues that, even if I pass the ground rules, might still be a problem in the future? So all those are considerations that you have when you're designing, because you're really thinking about, too, how reliable do I need it to be? Is it going to be reliable when I manufacture it? What's the likelihood it's going to meet performance? That's the other part as well. How much variability am I modeling in my design and allowing for? All those things come into play.
How much do you typically adapt to different companies? Like if a company wants something specific that you don't offer, are you willing to kind of like work with them to try and develop a new process, or do you only stick to like your specific kit?
Yeah, so with Global Foundries, definitely, talking about differentiating technologies, there's definitely activities and work on with customers in order to meet applications and needs. So that's part of the differentiation, is to be able to understand a customer need when a customer comes in and being able to apply maybe something process-wise, or especially something design kit-wise to meet their needs. So there's a certain type of model they need, a certain type of tool they need. That's something that would be considered and part of it. It's not the situation where we have a vanilla design kit and it always stays the same.
Okay, how to phrase this? I'm curious, as a foundry, getting a lot of different designs from different companies, how do you maintain confidentiality of the chip design?
Yeah, very good question. So our manufacturing teams, facilities, what have you, in terms of the design itself, have very strict controls on a customer design in terms of where it can be stored and who can access it. So those things are in place even within the company. So if you come and submit a design to us, not every person in the company can access it. It's going to be people on a need-to-know basis who have a reason to do as part of the manufacturing process. So for example, I can't go in and see every design, right? I don't need to know. I don't have a need for it. I'm not going to be able to go in and access it unless something happens that I need to be involved with it. And the same thing comes with, you're talking about EDA, right? And EDA software and EDA companies. That's also part of our challenge too, right? Is confidential of the customer design. We're not going to provide that design to them to look at, for example. So there's quite a bit of safeguards and boundaries that are put in place to make sure that customer design stays confidential. It's between us as part of the disclosure agreements, right? And that design and that customer, and to make sure people who access it only on a need-to-know basis.
So I know you touched on this briefly back in the beginning when you were talking about supply chain, but how is it that you sort of make sure that your supply chain stays up? And we saw this in COVID, especially how the chip supply chain was really, really bad. How is it that you're preparing for stuff like that, and how do you make sure it doesn't really happen again?
So this gets a bit outside of my domain too, so I don't have a very good answer for it in terms of where I am in the company and such. But I know that there's planning that goes on to ensure that there are paths, right, depending on what may happen geopolitically, to make sure that supply chain stays there. And that's a critical part of what we do, is to ensure we have that. So for example, during, COVID and what have you, we did not have, say, downtimes and what have you. We were able to keep manufacturing because we had those supply chains in place.
Yeah, hi. I remember you talked earlier about like taking some lateral moves in your career to,
Yeah.
kind of explore some other stuff.
Yeah.
What kind of so he was just talking about supply chain. What kind of opportunities does GlobalFoundries have? Like, if you were an engineer and you wanted to get into the business side, or if you wanted to get into more the management side, does GlobalFoundries have a lot of opportunities for those kinds of like lateral moves?
Yes, yes. Yeah, so there's definitely opportunities for lateral moves and being able to get more experience in different places. And personally from my side, and I'll give my example, I was able to do something where I'd been doing part of what we call the PDK for a long time. And within that, more say, I was modeling things, so I was very much a double E, put it that way. I was given an opportunity, and these opportunities come around, as I mentioned before, to take something completely different in software development and automation. Completely different realm than what I had done before. So those opportunities do come up. But in terms of being able to find those opportunities, yes, they are available within the company in order to say, if you want to get to the business side, right, to start looking into what I could do from a business point of view. Or if you want to get, if you're in the fab side, but you're interested in being more on, say, what we do in PDK, there's definitely opportunities there. Yeah, and it's not necessarily that there's a set and fast program, but there is an ability to, within the company, network, find what you want to do, and be able to work towards that into different positions. Yes. I'll back up here.
Being in a leadership position and like managing others, how do you keep them, at like full capacity, I guess, but like also being a good leader at the same time?
Yeah, very good question, because micromanaging is not the answer, right? It's not the day-to-day. So what I do as a leader, and I was showing the team earlier, I have a very remote team. Even though no matter where I sit, they're remote to each other. I have like 8 locations, 40 people, for example. So what we're looking for is what is the outcome, right? And so what I'm doing as a leader is I'm looking to see, okay, what are we trying to strive to? What is their outcome? What is their impact? What are they trying to produce? And we're really focused on that. So I'm not focused on, for example, checking in, hey, are you working right now? No, I'm not worried about that. What I'm thinking about is, okay, we have a project, we set a deadline, or we set a target. Are we meeting that target? Where are we at? If we're not there, why aren't we there? And having those kind of discussions and interactions as a leader. And that's how I gauge it in terms of, let's say, capacity and what have you. It's not micromanaging their time. It's what we get as an impact or an output. And then over time, we start to evolve that more and more, maybe become more efficient. But it is a very challenging thing in order working, in an engineering point of view, right? Where you don't want to micromanage, you can't micromanage, but what you want to do is manage the outcomes.
Question, feel free to stay and ask Cole. And then if not, let's give Cole a round of applause.